This lesson is about relations and functions. So this is example or section 2.1 from your book. Relations and functions. Okay, so we have a definition of relation here, which is what we're going to talk about first. And what a relation is it's just a relationship between two things. It's a set of input and output values. These are the two different things. And we can write a relation as a set of ordered pairs. So we've done that here in example 1. We have a relation, that's what's inside these curly brackets, and we are going to graph it. So you've already graphed relations before and you may not have known it, but so this point, this ordered pair, this is the xy values, xy. So if you go -2 on the x-axis and up to +4 on the y-axis, there's 1 point. If you go to +3 on the x-axis and then down to -2, here's another point. -1, 0, and 1, 5. Alright, so this is the graph of our relation. And then if we look over here, it says domain is the set of all inputs. So remember, a relation is input and output values. So the input values are going to be the x, and the output values are going to be the y values. So the input, a set, the notation for a set is these curly brackets. It looks like this. And then you write down all of the values in your set, and I like to write them in order from least to greatest. So -2, -1, 1, 3. Okay, those are all the values. They're all of the inputs for this relation. And then all the outputs are the y values. So these are the x values and now the y values. I'm going to do it in order also. So we've got -2 is the lowest y value. And then the next one is 0. And then 4, and then 5. So here's our relation, our graphed relation. This is the domain of our relation, all of the x values, and this is the range of our relation, all of the y values. Domain and range is a really important concept, and we're going to be doing this the entire year with every type of function that we do. So it's really important that you memorize what the domain is and what the range is. Example 2. We're going to now find the domain and range for this relation. So we have a relation graphed here, but we don't have the ordered pair values. So we could write out all the ordered pairs, and I'm going to go ahead and do that. This one is the point 2 on the x-axis and 4 on the y. So we went 2, 4. This one looks like 3, 4.5. 3, 4.5. This one is going to be 4, 7.5. This next one is going to be 5, 7. And then this is the next two are going to be 6. It's going to be 6, 5, and 6, 7.5. So 6, 5, 6, 7.5. Alright, so here are all my ordered pairs. Now if we're going to write the domain, we're going to write all the x values. So I'm going to go ahead and erase this. I'm just going to go from left to right and look at my x values. So the domain is 2, 3, 4, 5, 6 shows up twice. 2, 3, 4, 5, 6. You don't need to write 6 twice because what the domain is it's the set of all input values. So 2, 3, 4, 5, 6, they're all input values. You don't need to write 6 twice because it's already an input value. An incorrect way of writing this, sometimes students will say it's all the x's between 2 and 6. Okay, because 2, 3, 4, 5, 6. And that's good thinking, except it's not really all the x's between 2 and 6, because what about this x value? Well, that would be 3.5, and that's not one of our inputs. Okay, so in fact, it is not all of the x values between 2 and 6. It's only the integers between 2 and 6. The range is going to be the y value, so I'm going to go from bottom to top and write the y values. So the range and this is x values. The range is going to be 4. This looks like 4.5, 5. Next lowest one is here at 7, and then we have 2 that are at 7.5. So you only need to write that one once. So the range is 4, 4.5, 5, 7, 7.5. That is the domain and the range of this relation. Okay, another way to show a relation, instead of graphing it in a coordinate plane, you can make a mapping diagram. And what that is you take the relation and you write the domain, and usually from least to greatest. So the lowest domain value, these are the x values, so these are all your domain values. The smallest one is -5. -5. The next smallest one is -1. The next smallest one is 3. And it shows up twice, but we only need to write it once. Okay, then next we have the range values. That's these, the y values. The smallest y value is -10. The next smallest y value is -2. And then we have a +2 and 6. So we've written our domain and our range in order from least to greatest. And now what a mapping diagram is you show which input value maps to which output value. So we go up here and we look at -5. -5 and -10 are an ordered pair. -5 maps to -10. That's how you would say that. And then -1 maps to -2. And then 3 maps to 6. And 3 also maps to 2. So this is our mapping diagram for this relation. Domain in order, range in order, and then you show the connections here. So that's all you need to know for relations. Now let's talk about functions. A function is a type of relation, but it's a more specific type of relation. So in order for it to be a function, it has to have every single element of the domain has to go to exactly one element in the range. So you can think about a function kind of like a machine, okay? So here's a machine. And here's a little conveyor belt going in and a conveyor belt coming out. If you put something into this machine, let's say you put a little doll into the machine, okay? When the doll comes out of the machine, let's say the machine puts a dress on the doll. This is my beautiful art skills right here, okay? So that's what the machine does. The function, I'll call it D for dress, okay? It takes these little dolls in and it puts a dress on them. If you put something in here, you need this machine to always put a dress on the doll, okay? You need it to do the same thing. It needs to take this doll and make that doll, okay? It can't take this doll and make a doll that has, let's just say, pants on it, okay? You need the machine to do only one thing. You need to have one output for each input, okay? Now maybe the machine is a really smart machine and it knows whether or not it's a boy or a girl doll coming in, okay? And it takes girl dolls, let's say girl dolls have hair, okay? And it says, okay, if it has hair, then I'm going to put a dress on it. That's a dress. If it doesn't have hair, I'm going to put pants on it. So the guy comes out with pants on. Okay, and let's say that's what this machine does. So instead of D for dress, I'm just going to call this F for a function. Alright, so it's really important that a guy can't come in and get either pants or a dress. It's only one or the other. Now it's okay if you put in two guy dolls, two different guy dolls, and they both get pants. That's fine. And let me show you what this means in relationship to math. Okay, if you have an input value like -2, it can only go to one output value. This is like a guy needing to wear pants. Okay, he can't wear pants and a dress. or whatever else it is. So this is not a function. This domain is not a function, because you have this one value that two different things happen to it. That's a bad machine, when something comes in and two different outputs could happen. This one would be fine. Okay, it goes in, one thing comes out. It goes in, one thing comes out. That's what we want. Let's look at this one. Is this one a function? Why don't you pause it and see if you can figure it out. Okay, this one is a function. It is a function. And the reason why is every single domain value, each input, gives one output and only one output. -1 goes to 5, 0 goes to 3, 2 goes to 3, 3 goes to -1. They only go to one output. Now you might have looked and noticed that 0 and 2 both go to 3. Is that a problem for a function? No, it's not. This is kind of like the example that I said before. It's like you have two different male dolls. They both get pants. That's fine. It's just really important. It's really only important the other way. A domain value can have the same output value as another domain value, but one domain value cannot have two different output values. So if you need to look over this some more, definitely make sure you understand what makes something a function. Let's look at this graphically. Okay, so sometimes you're going to have graphs and you're going to have to determine, is this a function? Well, what we have is something called the vertical line test. And what the vertical line test says is it's a function if you can take a vertical line and go across the graph, and at no point that vertical line is touching two separate places on the graph. Okay, so this is the exact same thing that we just talked about. The x values are the domain. They have to go to exactly one y value. If they go to more than one y value, we have a problem. So let's look at that. Let's use the vertical line test. We go across. Is this purple line touching more than one point on the graph anywhere as we go across? The answer is no, so this is a function. So this one is a function. Let's test that with this other one. Okay, so here we're okay. It's only touching one point on the graph, but if we go a little bit farther, you can see now we're touching 2 points. Okay, we're touching here and here. That's a problem for a function. And now we're touching at 3 points. Okay, so this is definitely not a function. Not a function. And now let's talk about the x and y values that we were just doing before. So here, this x value, 1, only has one y value. It has the point 1, 1. Okay? Over here, -1 touches 1 also. So we have two different domain values, -1 and 1, that go to the same range value. That's okay. You still can have a function. But over here, you have 1, and it goes to, I don't know, let's say 0.9, but it also goes to almost, or 1, 2, 3, so like 3.9, and it goes down here to 1, 2, 3, 4, -5. So one domain value has three different range values. That's a problem. Okay, so this is not a function. And you can tell that by using the vertical line test. Alright, let's talk about some function notation now. Here's an example of a function rule. Okay, these things right here. I'm going to show you the different inputs and the output values. So input I'm going to put in red, and output I'll put in green. Oh, that didn't change color. Excuse me. Output I'll put in green. Okay, so the input is the thing that goes into a function, and then the output is what comes out of the function. So in this case, the x is what goes into the function, and y is what comes out of the function. So this is your input, x, and your output is y here. And the function rule is, for this case, is whatever you put into the function, multiply it by 2, and that'll give you the output. So for example, let's say multiply by 2 is what the function does. That's what this box does. This is a function. Okay, the input is 1. It goes into the function. it gets multiplied by 2, it comes out as 2. And now we have the ordered pair 1, 2. Let's say the input is 5. It goes into the function, it comes out as 10, and now we have the ordered pair 5, 10. You could do this as many times as you want, and that's what this function rule represents. It's saying all inputs multiplied by 2 give you the output. Alright, now let's look at the second one. Okay, the input value and the output value. See if you can figure out what they are. Okay, so the output is f of x, and that's how you read this, f of x. This is not f times x, which is what we're used to seeing with parentheses. It's f of x. It means the function is f, the input is x, and f of x is what comes out of the function. So x is your input, f of x is your output. So the function is, take your input and add 5. Okay, that's what the function f does. The function is f, and it says take your input and add 5. So if our input is 1, it goes into the function, it comes out as 6, and we have the ordered pair 1, 6. If it is -5, it goes into the function, it comes out, we add 5 to it, it comes out as 0, and you get -5, 0. And you can just keep doing this forever, actually. Comes out as 15, and you get 10, 15. Okay, so that's what this function f does. It takes your inputs, it adds 5, and it gives you an output. Alright, now this other one, this last function, the input is d, the diameter, and the output is c, the circumference. And what does it do? So this function is c. It takes the input d, it multiplies it by pi, and then gives you an output, pi times d. So in this case, the ordered pair would be d, c, okay, and c is pi times d, so I could have also written this like this, pi times d. So if d is 1, and it goes into this function here, it comes out as pi times 1, and our ordered pair is 1, pi. Alright, so you can do that with any functions. Alright, let's look at an example. The area of a square tile is a function of the length of a side of the square. Write a function rule for the area of the square. So they want us to make a function a that's for the area of the square, and then we'll evaluate the function for a specific length. Well, we know the formula for the area of a square. You have a square, it has a side. To figure out the area, you multiply the two sides together. So the area of a square is side squared. If we're going to use function notation to write it, we want to write a of s is equal to s squared. The area of a square, a of s, is the side squared. So here's our function. Our function a is area of a square is equal to side squared. Now let's evaluate it. We want to know what is the area of a square with side length 3.5 inches. Well, if our input is 3.5, that means we multiply it by itself. We square it. 3.5 squared. And this is equal to 12.25 inches squared. So the area for our function in this case, with the input 3.5, the output is 12.25 inches squared.